Hello, with this video, we're going to take a look at the questions that you're going to have to solve for me under assessment 1, which covers chapter 3.1 and 3.4. And then we're going to look at the solutions. So basically, I'm giving you some simple examples to practice before you challenge yourself on my math lab. So question 1 is saying that using the formula for simple interest and given values find interest. So this is the easiest question of the test. We have the principal amount, rate, and time, and we want to just find the simple interest. So simple interest formula is PRT. So first, before we do anything, we need to convert 7% to a decimal. So in order to find the interest you're going to earn over these settings, principal money is $300, rate is 0.07 as a decimal, time is 8 years, and when you multiply these three numbers, you're going to find out that the answer you're looking for, number one, is $168 for these numbers. Question 2. For question 2, it's a different concept. It's not simple interest anymore. It says we want you to use the formula. This formula, actually, this is still under 3.1. It is the simple interest formula, but this formula not only calculates the interest, it also calculates, it also takes into consideration your original input to the bank. So principal is 5,500, rate is 10%, and time is 3/4. So we want to figure out how much money you're going to have after 3/4 with this down payment and this rate. So the formula is already given to us. We just have to convert 10% to a decimal. And then we need to convert 3/4 to a year because simple interest formula only works with years. And then when you plug in the rate, time, and the p-value into the formula, you can find out your future value, future number you're going to see in the bank after this setup. Question 3 has 3 parts. So you have a $900 and you're putting into a bank on 13% rate, and you're going to first compound it annually and then quarterly and monthly for the 10 years. So we're going to find out the interest you're earning in each case. So this is the formula we need for these problems. It's because it's compound interest formula. So A is equal to P times 1 plus I to the power of N. So p-value is given as 900. 1 stays with me. I-value is the same thing as rate when it is annually because 13% is 0.13. And then when it is annually, you just have to divide 0.13 by 1, which gives you the same I-value. And N is the same as the years when it is annually because you're going to only get interest 10 times within this time frame. When you put this to a calculator, you will find your future value. This is the expected value. And then if you need to separate this, separate your interest earned from this money, you just have to subtract your original money from your final value. And this is how much interest you earned. We're going to look at the same problem when it is quarterly. As you can guess, this question has more value than the other questions on the test. So when it is quarterly, quarterly means M value is equal to 4. So in order to find your I first, you're going to divide your rate by 4 because it's quarterly. So this will be your I value. And then your N is not 10 anymore because quarterly means 4 and you have 10 years. So 4 times 10 is 40. That's where 40 comes from on the exponent. And as you can see, this amount is a little bit higher than the amount on part A. Again, when you subtract your $900 from this amount, you can find the interest you're earning with the option B settings. And then the same question, we're going to look at it monthly. And monthly means the M value is equal to 12. So to calculate the I, first we're going to divide 0.13 by 12. And this is, you can either leave it as a decimal or you can keep it as a fraction. We're going to use the same formula. And then this is our p-value, 1 plus, this is the I-value. Now, N is because you have 12, M is your 12, and you have 10 years. 12 times 10 is 120. That will be the power. And this is how much money you will be receiving after 10 years with this setup. And then if you subtract your original 900, you can only find how much interest you made with this setup. Question 4 on the test is a word problem. Again, it has part A and part B. So an investment company pays 10% compounded semi-annually. So as soon as I see this semi-annually, I know that M value will be equal to 2. You want to have $26,000 in the future. First question is, how much do you need to deposit now to have this much money in 5 years? When we look at the solution, because semi-annually means 2, and we have total of 5 years, the n value is equal to 10. So this is going to go to the exponent. This will be the power. If you want to calculate the I value, we need to divide R by M. So 10% is the R. Semi-annually means we're going to have to divide the R by 2. So this will be the I value. So this number goes here, and the exponent is 10. And this is the expected value in 10 years, and we're going to solve this equation for P. And then when you isolate the P, this is what the calculator is going to give you for this question. The same question has part B with the same setup. The part B is asking how much should you deposit now to have that amount in 10 years from now. So the only changing thing is the time is changing from 5 years to 10 years. So of course that's going to change our n number because semi-annual means 2. 2 times 10 is now the n value is 20. So 20 is going to be your exponent. I value stays the same because it's still semi-annually. And then when you plug in the numbers to the equation, this is the money you need to invest now to have this much money in 10 years. Question 5 is another word problem. A newborn child receives a $12,000 gift toward a college education from her grandparents. How much will the $12,000 be worth in 22 years if it is invested at 5% compounded quarterly? So quarterly and compounded, these are important to decide which formula we need. First of all, quarterly means n value is equal to 4, and the time we have is here 22 years. So when we multiply 4 by 22, the n value will be 88. So this is where this 88 comes from. That's the power. Now we're going to find the I value. I is when you divide the given rate by your interest periods. So since it's quarterly, we're going to divide the R by 4, and this is the new I value. Now, if you plug in the numbers to this equation, this kid is going to have $35,000, $805.03 after 22 years for this investment. Question 6 is on the quiz. It comes in 2 parts. First part, they're going to give you some numbers and some values, and you're going to pick the right equation and place numbers accordingly. Second part of the test is you have to find the number that this equation yields here. So it is asking you the future value formula. So future value formula is your PMT value, which is your periodic payments. So periodic payments are here, $67, parentheses. So 1 is in the equation plus your I value to the power of your n value minus 1 divided by your I value. And then when you put this expression to the calculator, it's going to give you the answer. Question 7 is, it says, use the future value formula to find the indicated value. So we're going to find the periodic payments. If the future value is 7,500, n is 32, I is 0.035. If you remember, we had a very similar homework question. And when I was explaining the homework question, I was telling you that the future value formula has been reorganized. And if you isolate the PMT value on that formula, to find your periodic payments, you have to multiply your future value by I over 1 plus I to the power of n minus 1. So if you plug in all the given numbers, future value is given, and then n value is given, I value is given. If you just put them to the calculator, you can find the answer for this question. Question 8 is, recently, more money for you offered an annuity that pays 7.5% compounded monthly. If $250 is deposited into this annuity every month, how much is in the account after 15 years? How much of this is the interest? Similar questions. Couple of things we need to pay attention. Compounded monthly, so month means we are going to deal with 12, and then the year is 15 years. So the easiest thing is we can calculate how many number of payments we're going to receive. So it's going to be 12 times 15, which will be 180 times we're going to receive a payment. The monthly interest rate I will be this as a decimal. That means just divide it by 100. And then we're going to divide that rate by 12. And then this will be the I value. If we now plug in the values to the formula, future value will be equal to your periodic payments and your 1 plus your I value, your N value minus 1 divided by I. And you can find the future value to be equal to this. Now the question is, okay, you're going to pay $82,778 for them. When you want to borrow $250 from them every month for the next 15 years, how much are you getting? How much are you paying for interest? Now, if you look at our payments every month, we're going to first pay $250 for them. And then we're going to pay it for 15 years, which is 180 times. And then this will be the money we're paying to them for the $5,000. So no, actually, this is the money we received from them, but this is how much we're paying them back. So if you subtract these two numbers, we can find the interest that we are paying to them. Question 9 is a straightforward question. It's just a formula application. It gives me the N value, I value, PMT value, and it just asks me to find the PV, which I can just go ahead and plug in them to the formula and I can find the PV. Question 10, American General offers a 17-year annuity with a guaranteed rate of 9.56% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $800 annually over the 17-year period? This is the formula we're going to need. In this question, the periodic payments are $800. We need to first find our I value, but because it's annually, basically we just need to divide the rate by 1 and we still get the same number for I. And N is 17 years times 1 because annually means just a 1. And then that's the 17. If we now plug in them to the formula and evaluate the answer with a calculator, this is the answer I get. And we're on the last question of the test, question 1. It says that eLoan, an online lending service, recently offered 42-month auto loans at 6.6% compounded monthly to applicants with good credit ratings. If you have a good credit rating and can afford monthly payments of $225, how much can you borrow from this eLoan company? What is the total interest you will pay for this loan? Okay. So compounded monthly means we're going to have to deal with number 12 here. And then our time is 42 months. So let's take a look at the solution. Again, as usual, first thing we're going to calculate is I. So 6.6%, this is what it means as a decimal. Divide this by 12 because they said in the problem that it's monthly. And then this is our I value. This is the formula we need for this problem. And then $225 is the monthly payments. This is the I value. And then N value is given as 42 because it's given in terms of month. I didn't have to convert it to anything. And then this will be the PV, present value of the loan. Okay, this will be the present value of the loan. This can be borrowed from eLoan for a car loan. Now, if we actually look at now, how much interest are we paying with this case? We're going to make them 42 times payments. Each payment is $225. So we're going to have to multiply 42 by 225 to see how much money we're actually paying them. And then this is actually the value of the car at this point, or the money at this point. So if we just subtract this, this will be the interest we are paying to them with this setup. This is the test 1 questions explanation.